Hello, students, and welcome to our algebra lesson today. We will start with our do now. Let's get a color that shows up well here. How about the white? We'll start with our do now. We are starting our new PBIS program today, so we're talking all about being our best. Our objective will be to learn about negative exponents today in our essential questions. What is the negative exponent rule? And how do I rewrite those negative exponents so that they are positive? Our assignment today will be to complete the do now, complete the 2 pages. There are 28 problems and some notes. Complete the exit ticket. Distance learners must submit their work on Teams. In-person learners, you have to show your work to me during class to get your full participation credit. You need to come to class with your notes. That's just something you need to do. They need to come back and forth with you. Sorry about that. That's all of our videos. Okay, for homework, we have homework 4, negative exponents, that are 21 very short problems. I believe it's 1 page. All Unit 5 work, we're in Unit 6 now, is due by 1:30 today. And remember, extra credit for that Pi Day contest. I'm going to kind of just be very quick with the do now because we have a lot to cover today and I want to get into it. But you have seen this before, our best expectations. I want you to think about those best expectations specifically with regard to hallway behavior, and I want you to write about that right there. So let's get started. There is today a today's special, super important. Okay, there will be some credit offered for those who can complete the challenge problem in class today. So let's get started with our lesson. Our lesson is about negative exponents. And to start us off, the negative exponent rule is when you have x raised to the negative a power, we simplify that by putting the x in the denominator and making the exponent positive. For example, x to the negative 5 would be 1 over x to the 5th. 3m to the negative 2 power would be 3 is still in the numerator. That negative 2 only applies to m, so m to the 2nd power goes in the denominator. Number 3, negative 7a to the negative 4 power, b to the 3rd power. The negative 7 and the b to the 3rd power remains in the numerator, and a goes in the denominator with a positive exponent of 4. So we're going to simplify these expressions, and please make sure that your final answers contain only positive exponents. Okay, so we're going to use the rules and then move the variables at the end. For many of these, you work from the outside in, but where you have multiple parentheses, you're going to work from the inside out. So for number 4, we have w to the 7th power times w to the negative 9th power. That would be w to the 7 plus negative 9, which equals w to the negative 2 power, and we simplify that by putting that as a denominator under a numerator of 1. Now, for number 5, 4 c to the 8th, d to the negative 3rd, times 5 c to the negative 5th, d to the negative 1st power. 4 times 5 is 20, and c to the 3rd power. When we multiply, we add exponents, and d to the negative 4th power. So we'll simplify that with 20c to the 3rd in the numerator and d to the 4th, now with a positive exponent in the denominator. So try the next few and on your own, and then come back to the video and let's see how you do. Okay, so number 6. We have 6x to the negative 8th power times negative 3x to the negative 3rd power. So 6 times negative 3 would be negative 18x to the negative 11th power because we've added those exponents. So in our numerator, we still have negative 18 in the numerator. In the denominator, we have x to the 11th power. Number 7, we have a, b, and c terms. So we have our interim step, a, negative 5 plus 7 is a to the second power. B, 8 minus 3 is b to the fifth power. And c, negative 12 plus 7 is negative fifth power. So our numerator will be a to the second, b to the fifth, and our denominator, c, now with a positive exponent of 5. Number 8, 8 to the negative 2 power is going to equal 1 over 64. And then our p, 5 times negative 2, is negative 10, because this is the power rule. So we simplify it. 1 is still the numerator. 64 is still the denominator, along with p now to the positive 10th power. Okay, number 9. 5 to the negative third power is 1 over 125, because 5 times 5 times 5 is 125. And then we have y, 2 times negative 3 to the negative 6th power. We'll simplify that with 1 in the numerator, 125, y to the 6th in the denominator. Number 10. 3 to the negative 4th power is 1 over 81. R is 1 times negative 4, negative 4. S is negative 3 times negative 4, which is a positive 12. We simplify that with 1 in the numerator, not done yet, 81 in the denominator, R in the denominator with an exponent of 4, and then the numerator contains our s to the 12th power, and the 1 now becomes invisible. We do not need to write the 1 there. So this is our final answer with s to the 12th power in the numerator, 81 r to the 4th power in the denominator. And number 11, 6 to the negative 2 power is 1 over 36. X, 5 times negative 2 is negative 10. Y, negative 4 times negative 2 is a positive 8. So in our numerator, this is similar to number 10, we're going to have y to the 8th power in the numerator. We can make this 1 invisible, and in our denominator, 36x to the 10th power. And number 11, we have, remember, when we divide exponents, we subtract. So this would be h to the 2 minus 5 power, which would be h to the negative third power, which would equal 1 over h to the third power. And number 13, again, we subtract exponents. So negative 2 minus 7 would be negative 9. D, negative 1 minus negative 2 is actually going to be a positive 1, because it's negative 1 minus negative 2. Let's put this over here. Negative 1 minus negative 2, which means we add, and that equals a positive 1. So that would be d to the first power. That 1 can become invisible. D moves into the numerator, and the denominator has c with a positive exponent of 9. And number 14, 14 divided by 7 is 2. W, 4 minus a negative 2, so 4 minus negative 2 equals 6. So that would be 2w to the 6th power. And number 15, negative 10 divided by 2 is negative 5. And then we have m2 minus 3, which is a negative 1. We cannot make that invisible. And then we have n, 1 minus a negative 5. Let's move over here. 1 minus a negative 5 is 1 plus 5, which equals 6. So that's n to the 6th power, which we rewrite into the numerator of negative 5n to the 6th power and m in the denominator. Now that the 1 is positive, we can make it invisible. So it's okay to have an invisible 1 once we've made it positive. So try these next 4 on your own, and let's see how we do. Okay, so number 16, 36 divided by 12 is 3. And then we have our x to the negative 4th power. And then we have y, 8 minus 7 is 1. So our fully simplified expression would have 3y in the numerator and x with a positive 4 exponent in the denominator. Number 17, let's reduce 15 over 18 by dividing each of those by 3, which will give us 5/6. And b, the a's would be eliminated. They would equal 1 because it would be a to the 2nd power over a to the 2nd power, which equals a 2 minus 2 is 0, and anything raised to the 0 power is 1. So the a's, since multiplication by 1 is an identity, we can eliminate that, becomes an invisible 1. So b, 5 minus 3 is 5 to the 2nd power. C, 8 minus 9 is c to the negative 1st power. So as we simplify this, we will have numerator of 5b to the 2nd power. And in the denominator, we have the 6 to go with our 5/6 and c. And then because the 1 is positive, it can become an invisible 1. Number 18, we have negative 4 divided by 8, which is negative 1/2. P, 1 minus 2 is p to the negative 1st power. Q, 5 minus 2 is q to the 3rd power. And r, 3 minus 10 is r to the negative 7th power. So let's rewrite that with positive exponents. And that would be 1 over 2. We'll get back to that 1. P is going to go in the denominator with a positive exponent of 1, which now becomes invisible. R with a positive exponent of 7. And then Q remains in the numerator with an exponent of 3. And then that 1 can become an invisible 1. It's implied. And number 19, negative 9 over 54 simplifies to negative 1 over 6. R, 2 minus 5 is r to the negative 3rd. S, 6 minus 2, x to the 4th. T, 4 minus 8 is t to the negative 4th. And so this will be very similar to number 18. Our numerator is going to have s to the 4th. And we can't forget that this is negative. So let's see how that works. We have negative 1 over 6. We have s to the 4th. In the denominator, we also have that r, which now has a positive exponent of 3, and t, which has a positive exponent of 4. But now that 1 in the numerator can become invisible. We do have that negative sign here, which takes care of that. So negative s to the 4th in the numerator, 6r to the 3rd, t to the 4th in the denominator. So now we have 6 mixed practice problems. So let's get to those. And it's going to take a couple of steps to complete these. So work carefully. So we need like terms in order to add. So let's work with these exponents from the outside in and see what we have. So 4 to the negative 2 power is 1 over 16. X 3 times negative 2 is x to the negative 6. Y 6 times negative 2, y to the negative 12, plus 2 to the negative third is 1/8. X to the second times negative 3, 2 times negative 3 is x to the negative 6, and y 4 times negative 3 is y to the negative 12th. Now we have like terms and we can add them. We have these like terms here. So 1/16 plus 1/8, well, we can think of 1/8 as 2/16. So 1/16 and 2/16 is 3/16. And we have x to the negative 6, y to the negative 12. And now we need to rewrite this with no negative exponents. 3 is still our numerator over 16. And we put y in the denominator with a positive exponent of 6. Oops, I forgot my x. We put x in the numerator first because we go in alphabetical order with a positive exponent of 6, and y in the denominator with a positive exponent of 12. The only thing in the numerator is the 3, and if I want to be nice and neat, I can move that over to the middle so it looks nice and neat. Okay, number 21 is very similar, but we don't have any leading coefficients, so in many sense, number 21 is easier. So x to the second, y to the third, all of that raised to the negative 2 power, x to the fifth, y to the fourth, and all of that raised to the negative third power. So x, we start with x. 2 times negative 2 is negative 4. Y, 3 times negative 2 is negative 6. And all of that will be multiplied by x. 5 times negative 3 is negative 15. Y, 4 times negative 3 is negative 12. Remember, when we multiply, we add exponents. So x to the negative 4 times x to the negative 15th is x to the negative 19th. Y to the negative 6 times y to the negative 12th. We add those exponents is y to the negative 18th. And let's rewrite this using positive exponents. So in our we'll move those to the denominator. We need a numerator of 1. Let's start with x. X to the 19th, y to the 18th, under a numerator of 1. Okay, number 22, we have some divisions. So let's multiply the top, the numerator, before we divide by the denominator. So 6 times 5 is 30. And a to the third times a to the ninth is a to the 3 plus 9, which is 12. And in the denominator, we have negative 12a to the 14th power. Okay, so first of all, negative 30 divided by negative 12. We can reduce that. Both of those are divisible by 6, so that would give us negative 5 over 2. And then we have the a, which is 12 minus 14, so that'll give us a to the negative 2 power. Now we use the negative exponent rules. We still have that negative 5 in the numerator, but our denominator has 2a with a positive 2 exponent. And number 23, let's work with the numerator first. So 3 squared is 9. And then we have x to the second power, y to the second power, times 2x to the fourth power, y to the third power. Okay, now we have 9, and well, let's put the numerator, 6x to the eighth, y. So now 9 times 2 is 18. X to the second times x to the fourth is x to the sixth power. Y to the second times y to the third is y to the fifth power, divided by 6x to the eighth, y. 18 divided by 6 is 3, and x, 6 minus 8 is negative 2. Y, 5 minus 1 is y to the fourth. Now finally, let's get rid of those negative exponents. So in our numerator, 3 can be thought of as 3 over 1. We can have 3y to the fourth, moving our denominator to the third, moving our x to the denominator, and the negative 2 becomes a positive 2. And this is our final answer. And then finally, number 24 and 25. We're dividing, so let's start with this exponent of 2 on the far outside. So we have the power rule here. So we've got negative 6 raised to the second power. So negative 6 times negative 6 is a positive 36. X, 4 times 2 is 8. Y, 6 times 2 is 12. Divided by negative 4 to the third power is going to be a negative. When you multiply negative number by an odd exponent, it will still be negative. So negative 4 times negative 4 is positive 16, but positive 16 times negative 4 is negative 64. So then we have x to the negative third times 3, which will be x to the negative ninth, and y, 5 times 3 is 15. Now, we start dividing. Simplifying 36 over 64, we can divide both of those by 4, so we would have 4 over negative 16, and x, 8 minus a negative 9, so remember that's 8 minus a negative 9, which would be 8 plus 9, so that would be x to the 17th power, and y, 12 minus 15, which would be to the negative third power. So let's put it all together. In our numerator, oh, sorry, I wrote 4. I divided by 4, that should be a 9. In our numerator, we have 9, we have x to the 17th power. In our denominator, we can put the negative sign here, we can put it outside, it doesn't matter. In our denominator, we've got that 16y, now with a positive exponent of 3. And our number 25, we've got multiplication in both the numerator and the denominator. So 6 times 3 is 18. We have b, 3 plus 5 is 8. C, 3 plus, oh, I'm sorry, b had a 1. I was reading this wrong. B has an invisible 1. So 1 plus 5 is 6. And C has the 3. 3 plus 2 is 5. Now in the denominator, 5 times 2 is 10. And B, 5 plus 3, here's our 8. And C, 6 plus 2 is 8. So now we simplify and subtract those exponents. So 18 over 10, those are each divisible by 2, so that becomes 9 over 5. B, 6 minus 8, so B would be to the negative 2. C, 5 minus 8 to the negative 3. And then getting rid of those negative exponents, we have a numerator of 9. in the denominator, 5b to the second, c to the third. Now, you see we have a challenge problem here. If you can complete the challenge problem in class and show all your work, you must show all work. So every step. When you do that, you will get 5 points on the next quiz. Has to be done in class, have to show all the work and every step. So there's your today's special. Let's go back to our exit slip. Explain the negative exponent rule. Okay, we ready to explain it in words? Probably a demonstration too. Negative exponents can be written using positive exponents. Okay, and how do we do that? We move the negative term to the other side of the fraction bar. That's the negative exponent term. And I would say that's its reciprocal. And then make the exponent positive. Okay, let's do our example. So we have x to the negative a would equal 1 over x to the a. Now, I didn't say move it to the denominator because sometimes these exponents can go from the denominator to the numerator, so you need to look out for that. So good job today. I'm so proud of your hard work. I know that with lots and lots of practice, you absolutely will be great.